The RollerCell 40 Multiple Roller Bottle Processing System, a revolutionary approach to large-scale tissue culture. The RollerCell 40 is a self-contained automated roller bottle processing system designed to automate all stages of tissue culture production in roller bottles. It promotes batch-to-batch consistency and helps to optimize yields. The RollerCell's unique ability to process large numbers of bottles simultaneously generates dramatic time savings, leading to significant reductions in labor cost and the virtual elimination of handling-related contamination. Traditionally, roller bottles have been processed manually by skilled operators trained in aseptic technique. Bottles incubated on standard roller apparatus are transferred to an area with laminar flow cover where bottle processing takes place. Manual processing is slow, labour-intensive and prone to contamination. Recently, robotic technology has been applied to roller bottle-based tissue culture. Robotic systems process bottles individually and sequentially, a robotic arm performing many of the handling tasks previously performed by human operators. Robotic systems are not able to process double-length roller bottles. The RollerCell 40 has been designed to automate existing manual roller bottle production protocols, enabling users to benefit from process automation without the need for expensive and time-consuming process development. The RollerCell 40 is suitable for all current roller bottle applications, including the production of human and animal vaccines, clean cells to inoculate fermenters, and the production of recombinant proteins for therapeutic applications. The RollerCell system consists of two main components, the RollerCell bottle processor and RollerCell bottle packs. The system can process any commercially available roller bottle, but is most efficient when used in conjunction with double-length expanded surface area bottles. RollerCell bottle packs are supplied gamma-sterilized and consist of 20 roller bottles ready assembled and ready to use. The bottle pack shown here is manufactured using 5x expanded surface area roller bottles and provides access to 84,000 square centimeters of cell culture area via a single sterile connection. The 5x expanded surface area bottle is the largest surface area roller bottle currently available. Once placed in the rotor, the RollerCell bottle packs enable all further processing to be performed without additional bottle handling by the system operator. RollerCell bottle packs provide a virtually closed production environment throughout the entire production process, significantly reducing the risk of handling-related contamination. To operate the RollerCell system, a sterile bottle pack must first be assembled into each rotor that is required for production. Each rotor has the capacity to hold 20 double-length bottles. If expanded surface area bottles are used, each rotor will process the surface area equivalent of 100 standard roller bottles. The double rotor RollerCell 40 has a capacity for 40 5x bottles, providing a total surface area of 168,000 square centimeters, or the equivalent of 200 standard bottles. Bottle loading takes an experienced operator approximately 15 minutes to perform, and once completed, no further bottle handling is required. If it's necessary to examine the cell sheet during the production process, access to individual bottles is simple to achieve and can be carried out without compromising the sterility of the system or the bottle. Once bottles have been examined, they may be placed back into the rotor and the incubation restarted or the next processing step initiated. The roller cell can be programmed to rotate continuously in one direction, as with conventional roller systems, or be programmed to alternate between clockwise and anti-clockwise rotations. In this mode, rotors will change direction every 3 or 4 complete rotations, or every 15 to 20 minutes. Changing the direction of the rotation does not affect the cell culture process, but it does enable bottle packs to remain connected to the media change assembly for the entire culture process, reducing the number of aseptic operations required and further reducing the risk of contamination. The umbilical tube supports ensure that the umbilical tube does not become twisted during this process. Once a bottle pack has been loaded into a rotor, the culture process may be initiated quickly and easily by connecting the rotor pump to the CPU controller. From the CPU, operators may control all process parameters. The roller cell simultaneously transfers up to 200 milliliters of media per minute in or out of each bottle in the rotor, enabling an entire rotor full of bottles to be filled or emptied in less than 3 minutes. Once bottles are seeded or the media has been changed, the roller cell is switched back to rotor mode, where it acts as a conventional roller apparatus for the duration of the required incubation period. As each rotor is controlled independently, one rotor may remain in motion, continuing its incubation phase, whilst the other is being processed. To start a processing step, the rotor is first brought to the home position. Once given the command via the keypad or at a pre-programmed time, the roller cell rapidly accelerates the rotor to the home position, where it comes to rest ready for the next process step. Rotors have a maximum speed of 12 RPM, a feature which promotes rapid processing during trypsinization and harvesting. The processing power of the roller cell system can clearly be demonstrated if a trypsinization procedure is considered. This is a complex processing step requiring a minimum of 4 complete fluid changes, a wash step and an incubation step. Lack of control at this critical stage of the culture process is largely responsible for poor yields and the wide variations observed in batch-to-batch consistency. Trypsinization of 80 2.5x expanded surface roller bottles with manual processing techniques would take 2 skilled operators over 9 man-hours to complete and require them to perform over 300 separate aseptic processing steps. With a RollerCell 40, a single operator can trypsinize an equivalent number of bottles in less than 30 minutes, involving only 4 aseptic processing steps. The RollerCell system has been designed to be user-friendly. CPU provides full operator prompt at each stage of processing. Complete production protocols may be programmed into the system to maximize consistency between production batches. Performance data has been generated by comparing the time taken to perform the main processing steps of roller bottle based cell culture. Data is shown for manual and robotic processes which use short-length 2.5x expanded surface area bottles, and for the RollerCell 40 which uses 5x double-length expanded surface area bottles. In each case, the number of bottles processed is equivalent to 200 standard roller bottles. Processing bottles manually, 2 operators would take a total of 15.5 man-hours to complete all 4 processing tasks and would require over 600 aseptic interventions. The robotic system requires just under 6 man-hours, whilst the RollerCell 40 system can complete the whole process in 90 minutes, involving just 14 aseptic interventions. The RollerCell Max has a modular design and is assembled from modified RollerCell 40 units under the control of a single microprocessor to form the most efficient and cost-effective roller bottle processing system available today. The RollerCell Max is particularly well suited to multi-harvest protocols. With a RollerCell Max system, a single operator can complete a full media change for the equivalent of 2,000 standard roller bottles in less than 3 hours, involving only 2 aseptic interventions. Because the RollerCell system can perform a media change without any bottle handling, little or no damage is caused to the cell sheet, which often becomes fragile towards the end of a multi-harvest protocol. The same process performed manually or robotically would require 33 or 15 man-hours respectively, and is likely to cause considerable disturbance to the cell sheet due to the repeated bottle handling required. At the production scale, the case for the RollerCell Max for multi-harvest application becomes overwhelming. The data shown here is for a multi-harvest protocol involving 5 media changes for the equivalent of 2,000 standard bottles. Performed manually, this task would take over 4 man-weeks, involving some 8,000 aseptic interventions. Robotic systems would require 2 man-weeks, whilst the RollerCell Max can complete the entire task in less than 10 man-hours, requiring only 10 aseptic interventions. The RollerCell 40 and RollerCell Max, the future of industrial scale tissue culture.